Okay, so be able to look at a topic called assignment problems. Okay, so I'm sure you're able to see this screen. Are you able to see the screen?
Yes.
So assignment problems, what is it all about? So assignment problems is where organizations assign workers to various workstations in order to actually minimize costs or maximize sales revenue. Okay. So that is where what assignment problems are about. So managers who assign workers to various workstations to do what? Minimize costs to maximize the revenue. Okay, so now in assignment problems, we use the method of Hungarian. Okay, what is this Hungarian method? So Hungarian method rules. Number one, you balance the table. That's a step one. So you balance the table. That is the summation of rows should equal to summation of columns. So these steps, you follow them properly when answering a question. So the balance the table, that is summation of the rows should equal to summation of the columns. So if the table is not balanced, you simply balance it by creating a dummy to either rows or columns where there is a problem. Okay, so that is step one. Then step two, we always solve the table or the problem a minimization. So if the table is for maximization, change it to a minimization simply by selecting the largest value from the table. Okay, largest value from the table. Then, okay, simply by selecting the largest value from the table, and you do what? And subtract other values from that number, including itself. So you solve the table as a minimization. So if the table is for maximization, you do what? You change it to minimization simply by selecting the largest value from the table and subtract other values from that number, including itself. That's the step two. Step three, you subtract the rows. Okay? So you subtract the rows and step four, you subtract the columns as per row table. So we'll be following these steps. We are going to be following these steps when answering the question. Okay. So subtract the rows, then the other one subtract the columns. So please note that as we subtract either rows or columns, we should select the smallest number when subtracting. So I'll show you how we select the smallest number when subtracting. Then step number five, we cancel most zeros. We cancel most zeros. Okay, so we'll be going step by step when answering a question. So I'll be getting you back to these steps, okay, as we solve a question. So the number of cancellations must be equal to number of either rows or columns. So number of cancellations must be equal to number of either rows or columns. So if the number of cancellations are not equal to number of either rows or columns, you select the smallest value from uncancelled numbers, subtract it from other uncancelled numbers, and add it back to where you have cancelled twice. So the number of cancellations must be equal to number of either rows or columns. So if the number of cancellations are not equal to number of either rows or columns, select the smallest value from uncancelled numbers, subtract it from other uncancelled numbers, and add it back to where you have cancelled twice. And the last one is assign where you have zeros in the table. Assign where you have zeros in the table. So these are the steps or rules of Hungarian method. So we'll be getting back to these steps as we look at a question. Okay, so Let us get to a question so far. Okay. A question we can pick up is this one. Okay. I'm sure you're able to see this question here. Are you able to see this question?
Yes, I can see it.
So the question says the marketing manager wants to assign salesmen to four cities. So you want to assign workers to various workstations. Okay. So he has four salesmen of varying experience. The possible profit for each salesman in each city is given in the following table. So salesman and cities, one, two, three, four. Okay, so one, two, three, four. We have those ones. So find out an assignment which maximizes the profit. Here they are saying find an assignment which maximizes what? Profit. So they are using which method? They want us to maximize profit. I said in assignment problem, you can either solve the problem as a minimization, right? Or as a what? You remember? I mentioned that you can either solve the problem as well, either what? You can either solve the problem or solve the problem as a minimization. So if the table is for maximization, what do you do? Change it to minimization simply by selecting the largest value from the table and subtract other values from that number, including itself. You remember this point, right?
Yes.
So now the from the word go, they said this is why organizations assign workers to various workstations in order to minimize costs or maximize profits or sales. So since this problem that you're given us is for maximization, first and foremost, you need to know is the table balanced? When the table is balanced, then you change it from the maximization to minimization. All right, so we'll be able to do two examples as we go so that you'll be able to see this is for maximization. Also need to do the other type in another class for minimization, what happens. Okay, so if it's for maximization, you change it to minimization simply by selecting the largest value from the table and subtract other values from that number, including itself. So as we come here, we have how many salesmen here? So let's do a solution. So from here, you have what? Salesmen. Okay, so, all right, so we have salesmen. And then what else do you have here? There are cities. Okay, so, um, okay, so this is what is going on. Okay, so we have city one. If I want, I can even say, instead of using city one, what I can just say A, let me use A, B, C, and D. These are cities. Salesman one, two, three, four. So what are we having here? 25, 27, okay, so 25, okay, so 25, the other one is 27, then 28, What else are we having? 38. Then the other one is 28, 34, then 29, 40. Okay, so you have a 40 here. Then you have 35. All right, so let's move on. So we have here 35. Okay, so 35, 24, 32, 33. Then we have 24, 32, 25, 28. So this table is it for maximization. So what you do, change the table to minimization. Change table to what? Minimization. How do you change it? Select the largest value from the table. So like I said, first of all, first and foremost, before you change, check if the table is balanced. Okay, check the table. Step one. What did I say about step one? Balance table. So balance table, summation of rows, equal to summation of columns. So meaning 4 rows equal to 4 columns, right? So table is what? Table is balanced, not so. You understand what I mean, right? Are we together? You understand what I mean? Okay, so, okay, no problem. So let's move on. So we are going to now change it. So this is number one. So step two, change the table to minimization. Change table to minimization. Select largest value from the table. Select the largest value from the table. So which value is the largest value from the table? You come and check here. Largest value from the table is which one? It's 40. So subtract all values from that number, including itself. So you're going to have A, B, C, and D. Okay, so this is what we have. So what is going to happen here is here we are going to have 15, here we are going to have 13, here we are going to have 12, here we are going to have a 2. So here you are going to have 12. Here you are going to have 6. All right, so here you are going to have what? 6 here. Here you are going to have 11. Here you are going to have 0. Here you are going to have 5. Here you are going to have 16. Here you are going to have 8. Here you are going to have 7. Here you are going to have 16. Here you are going to have 8, 15, and 12. So this is it from this table. So selecting the largest value from the table, which is this table, which is 40, subtract other numbers from that number, including itself. That's what it means here to say. Okay, so we have done the first component. We are now on step 2. We always solve the problem, the table to minimization. If the table is for maximization, change it to minimization simply by selecting the largest value from the table. Okay, and subtract other values from that number, including itself. Okay, so all right, so we have done step 2. So now we go into subtract the rows. Okay, so from here now we go into subtract the rows. Okay, so we are going to have step 3, subtract the rows. So subtract the rows. So what you do, you get a smaller number from each row to subtracting. You get smaller number from each row when subtracting. All right, so this is what goes on. Okay, so this is it, what goes on. So what is happening now here is you are going to select the smaller number here. So the smaller number is what? 15, 12 and 2, 12, 6, 11 and 0, 5, 16, 8 and 7, 11, 8, 15 and 12. Okay, so the new table here, okay, okay, so even you're going to have A, B, C, and D. Okay. And as we dismantle this table, what is going to happen is that since we have 1, 2, 3, and 4, the smaller number here, it is 2. Okay, the smaller number there is 2. So the smaller is 2, 0, 5, and 8. So as we subtract these two from other numbers, so it will be 13. So it will be 13. Here, 13, 11, 13, 11, 10, and 0. Then this other one to be the same, or the smaller number is 0. It will just be the same. 12, 6, 11, 0, 4, 6, 11, and 0. Number 3, it will give us 0, 11. So 0, 11, so 0, 11, 3, and 2. 3 and 2. Then the other one will give us what? Okay, 8, 0, 8, 0, 7, 8, 0, 7, and what? 8, 0, 7, and 4. Then you go into the other agenda. Which one is the other agenda here? Subtract the columns as per row table. Okay, so subtract the columns as per what? As per row table. Okay, so here, step what? Step 4. Is that a
Okay.
question? Hello?
Yes, I'm getting you.
Is it okay? Okay, I thought I wanted to get a question. It was a question. You are okay?
Yeah, though I'm a little bit behind because my speaker was off, so I
So,
couldn't get on the table how you're able to get the figures from the table.
okay, so subtract the columns. I'll get back a bit. Subtract the columns as per row table. As per row. Okay. So as per row table. As per row table. So what I'm saying is that here we change the table. Why were you behind when we change the table, or you were okay when we change the table?
Yes,
After
on step 3.
step three, we said you see this one now. Step two, change the table to minimization here, right?
Yes.
By selecting the largest value from the table and subtract other values from that number, including itself, which is this one. So we go to this
Which
table.
is 4.
We go to this table here. So here you are getting the smallest in each row. So the smallest
Okay.
was a 2, smallest was 0, smallest. Then subtract these numbers from each of these rows. So it will be 13, 11, 10, and 0. This one will not change because the smallest is 0. This one will be 0, 11, 3, and 2. This one will be 8, 0, 7, and 4. Right?
Okay.
Are you okay now?
Yes, I'm okay. So you're subtracting that from what? From 40, which
Which
is the
one?
highest,
Which one?
from the table. The way you're able to get the figures, the 15, 13, 12, and 2. Where are you subtracting them from?
Oh, we dismantled this table here. Since this table was for maximization, remember.
Yeah.
So we changed it to
Okay.
minimization. We solved it as a minimization. So we selected the largest value from this table, which was a 40. So we
Which is
subtracted
40,
all
yes.
these other numbers from 40 and including
From
itself.
40. Okay. Okay. Now I get it.
So
Okay.
15, 13, 12, and what? And then here 40 minus 40.
Thank you.
Subtracted all these
To
numbers
give
from
you
this
the,
number. Pardon? You understand?
yeah, I'm getting what I'm saying now. Understand? Yeah.
Okay, so this is what happens when it is actually, all right, when it is actually maximization. But if it was a minimization, there was no need to change it. We would have started straight away solving it. Uh,
Oh, okay.
we wouldn't have changed the table. So we have changed it because it was maximization. So we have changed it. The table that came up out was this one. After we get this table now, we subtract what? We subtract the rows. Subtract the rows. Not so. So
Yes.
select the smaller number in each row when subtracting. So the smaller number in each one was 2, the other one was 0,
So,
the other one was 5, the other one was 8. You understand now, right?
yes, yes.
Okay, so after subtracting this one will be 11, this one will be 13, 11, 10, and 0. This one will not change because the smaller number is 0. You are there.
Mm. Yes.
Then this other one will change to be 0, 11, 3, and 2. The other one will be 8, 0, 7, and 4. So this is how we have come up with this table here, right?
Mhm.
Are we together? So we are now on
Yes, yes.
step 4. So subtract the columns as a row table now. Subtract this column, subtract the columns, these columns as per this table. This table. We are not going back, we are not going backwards to the initial table now. We are just solving based on the previous table now.
Okay.
So it will still be A, B, C, and D. Okay, so what are we going to have here? Will be this. So we are still sorting out the issue. So please take note. You click on the same link. You get my point, right?
Yes.
When it runs out, click on the same link. Then we'll continue with class that we wrap up. So it will give us here. What's the smallest here? The smallest is 0 in the column. The smallest
Yeah.
0. The smallest here is 10. The smallest here is 0, right? How to
Mm-hmm.
get?
Yes.
So we are subtracting the columns as per row table. So meaning like this one will not change because the smallest is 0. So it will still be the same. 13 minus 0 it will still be the same. So it will be 13, 12, 0, and what else? And 8, right? Are we
Mm-hmm.
together? This other one will be 11,
Yes.
6, 11, 6. So it will be 11, 6, 0, 11, 11, 6, 11. So 11, 6, 11, and 0. So click on the same link shortly. Then,
Oh.
so this one will give us what? 7, the smallest there. So it will be
Oh.
7, 7, 8,